Today we're going to be looking at electrolytic cells, essentially the opposite of galvanic cells. And again, we'll be using a VCAR example to help illustrate the basics of an electrolytic cell. Now, in an electrolytic cell, we have a power supply connected, unlike in a galvanic cell. So one terminal of the battery will be positive and one terminal will be negative. Now, the negative one is where we will release electrons. One difference between galvanic cells and electrolytic cells is that in a galvanic cell, the cathode is positive. However, in an electrolytic cell, the cathode is actually negative. Now, our negative electrode is connected to the negative terminal. So in this case, this will be our cathode. And the one connected to the positive supply of the battery will be the anode. Now, a similarity between galvanic cells and electrolytic cells is that the cathode is still the site of reduction. So again, in electrolytic cells, we are using oil rig. Now, it's important to note at this stage that we are using molten sodium chloride, not aqueous sodium chloride, as you will often see to try and trip you up in questions. In this solution, we have an electrolyte. In this case, it is sodium chloride. Positive sodium ions will be attracted to the negative cathode. At this point, they will react with electrons that are gained from the battery. In this case, our reaction would be sodium ions plus electrons form sodium metal. Sodium is reduced at the cathode. At our anode, our chlorine ions would actually form chlorine gas. So in summary, a similarity between galvanic and electrolytic cells is that reduction always occurs at the cathode and oxidation always occurs at the anode. However, one difference between the two is that in a galvanic cell, the cathode is positive, but in an electrolytic cell, the cathode is negative. Hopefully, this will help you understand electrolytic cells a little bit more easily. Thank you for watching.